G'day Year 7s, and this is our last video tutorial for this unit on integers, if I can spit that out, on a Sunday night. Exercise 7G, the number plane, okay, which you have seen a little bit on in particular with your MathMate sheets. Okay, so a number plane is basically also called a Cartesian plane, which I think it talks about in here, which we'll go through in a sec, which is basically a grid. Alright, now that you've been introduced to integers and be able to use the negative and positive numbers, hopefully you'll better understand how a number plane or how a Cartesian plane can work. Alright, so just a bit of background info here. During the 17th century, two well-known mathematicians, René Descartes and Pierre de Fermat, I assume it's de Fermat, independently developed the idea of a number plane. The precise position of points are illustrated using coordinates. Okay, remember our coordinates, we use an x and a y coordinate. Okay, in brackets like that, with x always, and think of your alphabet when you're thinking coordinates, x first, always first, and then y. So just like your alphabet, x and y, that's the order you need to have them. Illustrated using coordinates, and these points can be plotted using the axes as measuring guides. So using these, so when you plot a point, for example, okay, if I plotted there, we can label that point, just say if it's point A, if I can write an A, is at x first, so it's going to be at 2 on my x-axis and up to 3 on my y, if I can do a proper comma there. Okay, and that's so it's very easily and precisely being able to dot precise points on these number planes. Okay, this invention revolutionized the study of mathematics and provided a vital link between geometry, shapes, and algebra. The number plane or coordinate plane is also known as a Cartesian plane. Okay, it uses two axes at right angles. So there's one axis, there's your second axis. Okay, at right angles that extend in both in positive and negative directions. So my x-axis, which is usually this way, the positive is that way. Okay, and my negative is that way. And with my y-axis, obviously the positive is that way, and my negative on my y-axis is that way. Okay, all right. So number plane, but also called a Cartesian plane. Okay, so the number plane uses two axes, our x and our y. Okay, so our x is always that horizontal line, and if you can't remember difference between horizontal and vertical, always think horizon. Horizontal, horizon. So if you're looking at the horizon out in the distance, that is basically your x-axis. All right, so it is that horizontal line. They're at right axles, each at right angles. Sorry, trying to speak a bit too quickly from my brain at the moment. Each axis uses a scale that includes both positive and negative numbers, as I've just described before. So my x and y are positive out this way and upwards, and negative is to the left and down. Okay, a point plotted on the plane has an x and y coordinate, which is written as x and y, remember, in that order. The x coordinate is written before the y coordinate as in the alphabet. Funny, I just explained it that way myself. Aren't I a clever little fella? Anyway, the point 0, 0 right here, okay, is called the origin, or O. Okay, so always remember that point there is called the origin. If you're ever asked to plot a point at the origin, it is right where those two lines, the x and y axes, meet. Okay, all right. I'm not going to go over too many examples here. It's going to be fairly quick and easy because you have been doing some of these in your MathMate sheet, so hopefully you've got a bit of a handle on them. We'll do a few different activities, do a little bit out of the textbook, but yeah, just getting used to plotting points and being able to identify points on a number plane. Okay, so for the number plane shown, write down the coordinates of the points labelled A, B, C and D. So what I want you to do is actually pause this video. Yes, again, I'm asking you to pause this video, write down the coordinates for each points of A, B, C and D, A, B, C and D, then come back and we'll check your answers. Okay, pause it now and off you go. It'll only take you a minute. Off you go. Thank you. Alright, welcome back. Hopefully you've paused it and not just continuing to listen, just to say, Mr. O'Donnell, this is boring, just get to the end of it. But anyway, we'll get to the end of it. Point A, sitting right here. Remember, we always do our x followed by our, wish I could do a comma, there we go, followed by our y. So our x number on our x-axis, where this dot of A is at 1. Okay, so my x-axis is 1, and my y is also even with 1. So my two coordinate points there is 1 and 1. For point B, okay, I'll look at my x first. So it lines up with my the third point on my x-axis, and it's obviously a positive. Okay, and my y, we're actually going down into the negative, so it is there, so it is at -2, so where 3 and -2 meet is my point B. Okay, so that's what you should have for that one, 3 and -2, or -2. Okay, you can use either of those terms. Point C, okay, so we're going backwards here on our x, so we're at -2 for our x axis, and we're at also -4 here for our y-axis. So -2 and -4 are your coordinate points. And last but not least, point D up here. So looking at x first, which is at -3. So -3, and then we look across to our y, and it is also at +3. Not also, but is at +3. So there are 4 points. 1, 1 for A, 3 and -2 for B, -2 and -4 for C, and -3 and 3 for point D. Okay, that easy. Again, not too difficult at all. We'll do hopefully a few different little activities in class for this one. But that is all we need to do. So nice, short, quick video. And we're just about done. Thanks, guys. See you in class. Bye-bye.